Module 7, Lesson 2 is a continuation of Module 1's lesson, only now you'll notice that there's some parentheses going on here. That means that we're actually going to be using the distributive property in solving these problems. I think that y'all can handle this. In fact, I'm pretty darn confident you are, so let's take a look at what it's going to hold. First off, our suggested pacing claims this is going to be a 2-day lesson. The lesson goal says students will solve two-step equations in the form of P times the sum of x and q, all plus equals r. Our inquiry question asks, how can algebra tiles help to solve two-step equations containing parentheses? To find out, let's get into this and see what they have to say about it. If you look at the bottom of your textbook here, your book gives us a video, so let's watch our video and see their instructions.
Use algebra tiles to solve two-step equations. P times the quantity x plus q equals r. Use algebra tiles to solve 2 times the quantity x plus 4 equals 12. To model the equation, place two groups that each have one x tile and 4 yellow tiles on the left side of the mat. Place 12 1 tiles on the right side. Arrange the tiles into 2 equal groups on each side of the mat. Each group is equal to x plus 4 equals 6. You can solve for x in each group. In the first group, remove 4 1 tiles from each side of the mat. Perform the same steps with the second group. For each x tile, there are 2 1 tiles, so x equals 2.
Well, that was pretty straight simple. I think we can handle some of those, so let's get out of this screen and go back and do the one they gave us. The problem is 2 times the sum of x and 6 is equal to 16. Going to have to drag a lot of things down, so we got 2 groups of x and 6, so that's 1, 2, 3, 4, 5, 6, and then again a second group of x and 6, 1, 2, 3, 4, 5, 6. Next, we're going to put 16 ones over into the other side, so that's going to be 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to work to get these kind of grouped together with the 2 x's. 1, 2, 3, 4, 5, 6, 7, and 8. So now I've got the original equation they said, which is 2 times the sum of x and 6 is equal to 16. Now we're going to start taking ones away from each side. So I'm going to take from the first group 1 and 1, 2 and, come on, get rid of it, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. And what does that leave us with? X is equal to 2. Now I'm going to do the same thing with my second group. 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. So in the end, in both parts, x's value is going to equal to 2. You got 2 x's and 4 here. You divide both sides by 2. X is equal to 2. Easy math. Now your textbook offers another similar type problem here that you can do on your own. I'm going to skip this one because I would much rather get into solving some real equations than playing with toys. An equation like 2 times the sum of x and 6 equals 14 is in the form of 2 times the sum of x and p is equal to r. It contains 2 factors, p, and the sum of x and q, and is considered a 2-step equation because 2 steps are needed to solve the equation. Now we're going to take a look at the animation to see how the textbook says to solve it.
One way to solve an equation of the form p times the quantity of x plus q equals r is to first apply the distributive property. Multiply each term inside the parentheses by the number outside the parentheses. Then simplify. Next, solve the resulting two-step equation. In this example, first subtract 6 from each side of the equation. Then divide each side by 3. The solution of the equation is x equals -8. Another way to
Now that is a really good way to do it. In fact, that's the way I'm going to do it most of the time, but they're going to show you another way involving division, and I think you're going to like that way too. Probably not as much as this way, but I think you're going to find it's pretty
Another way to
useful.
solve this equation is to first undo the multiplication by dividing each side of the equation by the number outside the parentheses. In this example, divide each side of the equation by 3, then simplify. Next, solve the resulting one-step equation. In this example, subtract 2 from each side of the equation. The solution of the equation is x equals -8. To check the solution, start with the original equation. Replace the variable with the solution. Then simplify to check whether the sentence is true. If so, the solution is correct.
Alright, they showed us two different ways to skin the cat, and both of those ways are perfectly good. You get to use either way you choose when you do these problems. And that leads us straight into example 1. Example 1 says 3 times the sum of x and 5 is equal to 45. The textbook is going to give us some examples on how to work it. Let's see if I like what they do. Well, I think I'm going to. So they just started off with the original equation. That's the first thing they did, is they wrote the equation. After writing the equation, they've got choices. They can use a distributive property to distribute through their grouping symbol, or they can divide both sides by 3 to isolate the variable that way. They chose to do the division. They're dividing both sides by the 3. These two 3's here, they're going to divide each other out, leaving x plus 5 on the left, and then 45 divided by 3, that's going to equal to 15. From there, they subtracted 5 on both sides, isolating the variable the rest of the way to get the final answer of x is equal to 10, which is what they would actually circle and put in their box. Now using method 2, it's going to be the same exact problem, only now we're going to use a distributive property. They started off the same way, writing the equation. After they wrote the equation, they distributed this 3 through the grouping symbols. 3 times x is 3x. 3 times 5 is 15. Now it's just like the two-step equations that we worked last night in the previous day's homework. So we're going to undo addition and subtraction by subtracting 15 from both sides, here and here. The 15s on the left are going to zero out, leaving x is equal to 45 minus 15. That's going to be 30. Next, divide 3 on both sides to undo multiplication and division. That's going to be the last step in isolating our variable. The 3's on the left divide out, becoming 1. 1 times x is x, and 30 divided by 3 is 10. Either way you work it, your final answer is going to be the same. X is equal to 10. So which method is going to be the best? It depends on the problem you get. Method 2, it is a surefire going to work every single time, but it has a few more steps in it. Method 1 can work really, really well if the number over here, in this case our 45, is divisible by the number right here, which is the 3. 45 was divisible by 3, so that makes that one pretty easy. If your number on the right is not divisible by the number you're dividing both sides by, I would encourage you to use a distributive property. Otherwise, you're going to end up with decimals or fractions you have to chug your way through instead of just being able to do some straight basic calculations. And now it's going to be your turn. Pause the video, work this problem, show me what you did. Now it's my turn. First question I need to figure out is, which method do I want to use? And the question I would ask for that is, can I divide that number by this number easily? And the answer is yes, I can. They're both divisible by 7, so or negative 7 in this case. So that's what I'm going to do. Whoops, drew that line too far. I'm therefore going to start off by dividing by negative 7 on both sides. On the left, the negatives divide out, 7's divide out becoming 1, and 1 times the sum of 6 and d. Well, that's just going to leave me with the sum of 6 and d. On the right-hand side, 49 divided by 7 is 7, and a positive divided by a negative, that's going to give me a negative. Next, I'm going to undo addition and subtraction by subtracting 6 from both sides, here and here. And when I do that, those zero out, and that's going to leave me with d is equal to, signs are the same, find the sum, which is going to be 13, and the sign in front of your larger number goes in front of your answer, giving us d is equal 13 for our final answer. I'm going to jump over here, put in, what was that, 13? That's negative 13. D is equal to negative 13. Check my answer, and it checks. Nothing to work in these problems. Now, example 2 is a very similar problem where now we have 5 times the difference of n and 2 is equal to a negative 30. And once again, there's 2 ways to solve them, and either one of those ways is going to be a perfectly acceptable method. The first method, to use the division approach, and you ask yourself, is 30 or negative 30 divisible by 5? The answer is absolutely yes. So they divided 5 on the left and right, like you see right here, and from there, these 5's divided out, leaving 1 and 1 times n minus 2. Well, that stayed to be your n minus 2. On the right-hand side, negative 30 divided by positive 5, that gave us a negative 6. From there, they undid addition and subtraction by adding 2 to both sides. The 2's on the left zeroed out, and on the right, signs are different. Find the difference with a sign in front of your larger number going in front of your answer, giving you a negative 4. Easy math. The other method, method 2 for them, is going to be to use your distributive property, and you can see right here that's exactly what they did. They took this 5 and they distributed it through the grouping symbol. 5 times n is 5n, 5 times negative 2, that's negative 10. From there, they undid addition and subtraction just like you would do any normal two-step equation, subtracting or adding 10 on both sides. You can see right here, the 10's on the left zeroed out, and on the right, signs are different. Find the difference with a sign for any larger number going in front of your answer, giving you a negative 20. Now you have 5n is equal to negative 20. You're going to undo multiplication and division by dividing 5 on both sides. 5 divided by 5 is 1. 1 times n is n. Negative 20 divided by 5, that's going to give us the same negative 4 that we found the other way. Either way you work the problem, you're going to get the same answer of n is equal to negative 4. And now it's going to be your turn again. Solve this problem. Pause the video while you do it, and then let's see if you can get the right answer. Now this would be a perfectly good problem to use the division approach on it, but I did that last time, and you know I get bored doing the same thing every time, so I'm going to use the distributive property this time to see how it works. So we're going to start off here with, get my cursor working, I'm going to take and distribute this negative 2 through the grouping symbols. So a negative 2 times y is a negative 2y, and a negative 2 times a negative 3, that's going to become a plus 6, and of course it equals 22. From there, I'm going to undo addition and subtraction by subtracting 6 on both sides. The 6's on the left, you can say goodbye to them, they're gone, leaving a negative 2y. And on the right, 22 minus 6, that's going to leave me with a 16, and of course there's an equal sign between them. Now I'm going to undo multiplication and division by dividing the negative 2 on both sides. The negatives divide each other out. 2 divided by 2 is 1. 1 times y is y. And then 16 divided by 2, that's 8, with a positive divided by a negative, giving us a negative 8 to circle for our final answer. Jump back over to the textbook, plug back in our negative 8, check our answer. The answer checks. There's nothing to solve in these problems. Now that's going to be it for part 1 of this video. When we come back, we're going to do example 3, where we're doing the same basic thing, only we're going to throw a fraction in there just for fun. I'll see you in part 2 of the video.